You are one of the worst designed creatures in the solar system. Tardigrades survive vacuum, cockroaches survive radiation, wood frogs survive being frozen solid, Pompeii worms live inside active volcanoes. You? You need socks. So what happens when the universe calls your bluff? What happens when you step onto the moon with absolutely nothing on? Not a guess, not a movie, the real physics. Second by second. First, let's get one thing right that Hollywood always gets wrong. You do not explode. Your skin is strong enough to hold you together. Your blood does not boil at first. Those are the myths. Here's what actually kills you. And when. The moon has no atmosphere, zero, none. Earth's atmosphere presses about 101,000 pascals on your skin right now. On the moon, that drops to essentially zero in the time it takes to blink. Your body has been pressurized from the inside your entire life. Remove the outside pressure, and that changes fast. Second zero, you step out. The vacuum hits instantly. Your first instinct, hold your breath, is the worst thing you can do. The air in your lungs would tear them open like a balloon. The correct move is to exhale everything immediately. Not that it saves you, it just changes the order. By second three, the saliva on your tongue begins to boil. Not from heat, from the absence of pressure. At low enough pressure, water boils at body temperature. Your tongue is just the beginning. The moisture on your eyes starts to go next. You would feel a strange cold tingling across your face. That is ebulism, gas bubbles forming in your tissues. It sounds like science fiction. It is documented. A NASA technician accidentally depressurized his suit in 1965. He was conscious for about 14 seconds. His last memory was the saliva boiling on his tongue. He survived. The suit was repressurized in time. On the moon, there is no one to repressurize anything. So, 15 seconds in, you are unconscious. Not dead, unconscious, this is important. The oxygenated blood already in your brain keeps you technically alive. That window is roughly 90 seconds. Astronauts training for this exact scenario know 90 seconds is the window. Rescue within 90 seconds, survivable. 100 seconds, permanent brain damage. 10 seconds, that is your entire margin. Now let's talk about what the moon is actually doing to you the whole time. The moon is not one temperature, it is two extremely violent ones. Sunlit side, 127 degrees Celsius. Shadow side, minus 123. That is a 300-degree swing with no atmosphere to buffer it. On Earth, air redistributes heat. On the moon, there is no air. If you land in sunlight, the ground under you is a frying pan. But you are already unconscious, so you feel none of it. The heat, however, is not your biggest problem. The moon has no magnetic field worth mentioning. On Earth, that field shields you from solar radiation every second of your life. On the moon, the solar wind hits you directly. Charged particles, ultraviolet, cosmic rays, all of it. The dose you'd absorb in an hour would give a radiation worker their entire annual limit. But again, you're not surviving an hour. Let us be precise about what is actually killing you, in order. Number 1, hypoxia. No oxygen in, brain shuts off. This is what actually ends you. Not the vacuum, not the cold. The oxygen in your blood runs out roughly 2 minutes in. Cardiac arrest follows within minutes of that. Number 2, ebulism continues. Your tissues swell grotesquely. Your body can swell to twice its normal volume. The skin holds, you still do not explode, but the circulation inside has essentially stopped. Number 3, decompression sickness, but accelerated to an extreme. Dissolved nitrogen in your blood comes out of solution instantly, like shaking a carbonated drink and opening it all at once. This is why astronauts pre-breathe pure oxygen before spacewalks. It flushes nitrogen out, so there is nothing to bubble when pressure drops. You did not pre-breathe, because you are reading a YouTube description, not a mission brief. Now, let's talk about the cold. You might assume you would freeze instantly. You would not. In a vacuum, heat can only leave your body by radiation. Radiation is slow, far slower than convection or conduction. Without air to carry your heat away, you cool very, very gradually. If anything, on the sunlit side, you might actually overheat first. Spacesuits are actually more worried about heat than cold. The suit's job is to radiate your body heat away fast enough. Without it, you are a sealed container with no exhaust. The moon's silence, by the way, is absolute. Sound needs a medium. In a vacuum, there is no medium. You would hear nothing. Not even your own heartbeat. Step back and look at what the moon actually is. Not a romantic backdrop. A kill zone. No air, no pressure, no sound, no shield, no mercy. And yet, humans went there 6 times and came back. That is not a small thing. Now, let's ask the question nobody actually asks. Is there any version of this where you survive longer? There is a loophole, a real one. Scenario: you are in a sealed pressurized chamber that opens directly onto the lunar surface. You step outside, but the door stays open. You stay in the doorway. The pressurized air from inside floods slightly outward around you. This is not science fiction. It is basic fluid dynamics. This has actually been studied in the context of emergency protocols. Extend your exposure, but stay right at the threshold. Keep the pressure gradient in your favor. You could potentially extend survival from 15 seconds to a minute, maybe 2. Still not survivable, but not instantly fatal. The difference between 15 seconds and 2 minutes is enormous in rescue terms. This is why emergency protocol design on the moon matters right now. Artemis is planning crewed lunar missions this decade. Engineers are genuinely solving the question we just asked. Because on the moon, 15 seconds is the difference between a mishap and a headline. Now let's run the full timeline. Start to finish. 0 seconds. You step out, pressure drops instantly. 3 seconds, saliva boils, eyes dry, skin tingles. 15 seconds, unconscious, brain switches off to protect itself. 90 seconds, the rescue window closes. 2 to 3 minutes, cardiac arrest, the body continues to swell from embolism for the next hour. Then radiation begins its slower work, eventually freeze-dried by the cold, preserved in the vacuum. With no air to decay you, no bacteria, no rot, you would lie on the moon, perfectly preserved, essentially forever. The moon would become your tomb for 1 billion years. Which raises one final thing. The spacesuit was not designed by a genius in a lab one afternoon. It was built mistake by mistake across decades, each failure teaching the next iteration. No master plan, just accumulated accidents that happened not to kill anyone. The thing standing between you and 15 seconds on the moon is a series of near misses. Every astronaut who walked on the moon was protected by failure. The saliva on your tongue is still the last thing you would feel. If you want the next one, the algorithm needs a signal. Subscribe.